Hello, good evening students. Let us try to understand problems and mechanism of dehydrohalogenation of alkyl halide. Okay, so first of all we have to understand what is meaning of the dehydrohalogenation. Now student, that is what the term is there here, the term D. D means what student? Removal. Okay, D means removal. Here is that is hydro is there. Hydro means removal of what? Hydrogen. Okay, removal of hydrogen, and then halogenation is there. Second point, we have to remove the halogen also. So these two things we have to remove. What the third point, that is reagent what we have to use student in this process? Alcoholic KOH. Alcoholic KOH. Okay, this is the strong base that we have to use, right? Now students, you see that is dehydrohalogenation we can study from the here from the alkyl halide. So it is what is there student? This is the chloroethane is there, chloroethane, right? Chloroethane. Dear student, what will happen if you are treating with the alcoholic KOH? So what it is going to do is student, what it is going to do, it is going to do that is E2 elimination, E2 elimination, A2 elimination, and as a result it will form that is CH2 double bond CH2, then it will give that is KCl plus water molecule will be released. Okay, let us have a look over the mechanism student. Okay, so mechanism here is in this one E2 elimination, in the E2 elimination, E2, okay, E2 elimination, always keep in mind student, L2 elimination, in A2 elimination no rearrangement, okay, no rearrangement occurs. In E2 elimination no rearrangement occurs. This is the first point. Okay, second point, if you talk about if there is no rearrangement student, second point is what? No carbocation form, no carbocation formed. Third point, beta hydrogen eliminate, beta hydrogen, that is you keep in mind student, which hydrogen is going to eliminate, beta hydrogen eliminate. Okay, means if there is no beta means there will be no elimination. Fourth point, okay, transition state form, transition state form, okay, transition state form. One more point which is there very important in transition state, if you the most important point there is the backside attack take place, backside attacks take place, attack takes place. This point you need to memorize student. Okay, then only you can be able to understand. First point, what I am saying, in E2 elimination no rearrangement of occur, rearrangement of no carbocation form, so no carbocation arrangement. Beta hydrogen eliminates, transition state form, backside attack takes place. So let us have a look. Here we are having the hydrocarbon. Okay, this is the Cl. Okay, here these all are what student? These are the hydrogen. Okay, K alcoholic KOH is, if you are saying it is the strong base, so 100% it will alkylize and it will give that is OH minus. OH minus ion, what it is going to do, it is going to attack on this carbon, this hydrogen. If it is attacking on this hydrogen, this bond has to shift here and this bond has to leave here. Okay, so firstly it will form the transition state student. Let us see the transition state. How can you be able to understand the transition state? So here you see, here is hydrogen is there, this bond is getting split here. Okay, so dot dot line, here is that is OH bond is getting formed, right? Here is the single bond is there, one more bond is getting formed, right? Here is downside hydrogen is there, upside hydrogen is there, here is hydrogen is there, no problem, here hydrogen, and Cl bond is getting removed. This is the very slow step student, and RDS it is known as rate determining steps. Okay, now it is very fast, very fast. What will happen student, this bond is getting split, so it is what is happening at the end for at the end this completely get formed here and this completely get broke here. So here what is happening, H2O is getting formed, here is C double bond C, okay, here you can write that is H2, here is CH2, and that is Cl minus is out. So that is what is the ethene. So from the chloroethane you got here the product, student. So transition, this step is what is transition state, highly active energy state is known as transition state. So this is the one mechanism. Now let us have a look over the 2 degree alkyl halide. We are having that is CH3, then we are having CH3Br, and here is CH3. So that is 2 degree alkyl halide, 2 degree alkyl halide. So dear student, if you are going 2 degree alkyl halide, you take the alcoholic KOH, right? If you are taking alcoholic KOH, it is going to give the product like CH3, CH double bond CH2. So it is 1, 2, 3, meth 8 prop. So this is what is known as propane 1 all. This is. Now let us try to have the mechanism, student. This is the, I am trying to have the mechanism. So dear student, if you are trying to understand mechanism, the same way it is going to attack, students. Same way it is going to attack, right? Now this is the alpha carbon, this is the alpha carbon, alpha hydrogen, and this is beta carbon, this is also beta carbon. So any place it can attack. So let us have the look over the mechanism. Okay, overall we are going to, here is CH, here is CH3, this side I am making that is CH2, and here is hydrogen. That is, that way I am explaining. Alcoholic KOH I have taken, alcoholic KOH, so it is 100% eliminating, so it is giving K plus plus OH minus. So here we can write here OH minus. So it is giving the, here is the bond. So if it is going, so it is forming double bond. Okay, here is CLB, no, here is suppose what is there, student, Br is there. So if Br, so this has to leave, this has to leave. But since it is the E2 elimination, this is E2 elimination. So E2 elimination is single step, it proceed in single step. Here you see, student, 6 point, it proceed in single step, it proceed in single step, right, student? So let us have a look over it. So if it is proceeding in single step, so what that is, transition state will form, student. So transition state, how it will be the transition state? So here you see, student, CH2 is there, and here is the one bond is getting formed. Okay, so what is, this is the OH, right? And here is, if you are taking, student, CH, right? Here is what is there, student, CH3, and this bond is supposed to leave, okay, Br, but here is what is the double bond has to form. Okay, this is the TS transition state, and this is also known as RDS, rate determinant step, that is slow step. After that it is very fast, it will happen, student, fast. And what the product is, it is going to give, student, that is water is getting out. Here is hydrogen is there, student, that is water is getting out, H2O, and right, and here is this bond is getting split completely, going here, and this is completely shifting here. So what will be giving is, student, CH2 double bond CH, here is CH3, plus it will give Br minus. So what it is, student, prop, no, 1 in, prop 1 in. So 1, 2, 3, this is prop 1 in. This is our required product, dear students, right? So dear students, that is 2 mechanism we understood here. Now we are going to understand the third mechanism. How can you be able to understand the third mechanism? Okay, so let me have the question from the books, students, so that I can be able to give you the proper mechanism here. So dear students, let us write the bond line formula for one compound I am giving you here. This is the there, okay, this is the Br, okay. Now if you are taking the alcoholic KOH, student, alcoholic KOH, so how the product will be there, student? This will give the product like that, okay. This is the major product will be there, student, major product, okay, major product, and one more product is possible, student, that is a minor product, okay, minor product, right. Dear students, what we have to do, we have to understand the mechanism of this reaction, right. So this is the, what is that is 1, 2, 3, 4. no, 2-bromobutane. Okay, 2-bromobutane is there, 2-bromobutane, and here is what is the major product is 1 2 3 4. So what there is student, butene. Okay, butene. This is stable, this is unstable. Why unstable? Because we know student, that is so many video series I am giving you, greater the number of alkyl group, greater is the stability. One alkyl group, two alkyl group, so 2R group is there more stable. Here is only 1R group, so that is less stable. Let us have look over the mechanism student. Mechanism, I already told you the mechanism is followed by single step. So here we can write here there student, here is Br is there. Okay, if you are writing the extended version of this molecule, you will find that is here is also hydrogen, here is hydrogen. Okay, 2 hydrogen are here, and here is the hydrogen is also there student, hydrogen. This place also, that is all the places hydrogen are there. Okay, so these are the, this is the beta hydrogen, this is also beta hydrogen. If you are taking that is alcoholic KOH, alcoholic KOH, so it will give that is K plus plus OH minus. Okay, so OH minus, I told you student, that is from the back side there will be attack here. So OH is attacking here this hydrogen, and this bond is getting shipped here, and bromine is getting out. So you can see out here what the product will be looking like. So this is, there will be the double bond, and Br is all out. So that is what will be there student, butene. This is our required product students, right? Now students, now what you are going to do, okay, let us have look over the next problem. If, okay, if I am taking the one more compound students, the compound is looking like this. This one, here is bromine is there student, here is methyl group is there. Okay, so if you are treating with the alcoholic KOH student, the major product will be what student, that have the maximum number of alkyl group. So what will be there student, here you see this is the alkyl group, so here will be, this is the major product student, this is the major product, right? This is the major product student. So suppose it is there compound 1 2 3 4, this is the 3 no 2 bromo, this is the 2 bromo 3 methyl, this is 2 bromo 3 methyl butane. And what we are getting student, here you can do numbering 1 2 3 4, so 2 methyl butene, 2 methyl butene, this is our major product students, right? So that is what we are studying. Now dear students, suppose I am having the compound, we can take students. Oh, let me check out the problem students, where we can find out the better problem. Okay, let us, I got the problem student. Here I am having the one more compound students, this is the compound here, and this is the methyl group, this is the Br group. Okay, and we are treating with the alcoholic KOH, right? So what kind of product you are expecting here student, what product? Here is hydrogen, here is hydrogen, here is hydrogen. Okay, here is 2 hydrogen are there, so that is bromine has to be lost, so here is double bond has to be kept out. Okay, so dear student, if you are treating with, this is the product, required product is what student, that is the product, and here is the methyl group. Okay, this is only one methyl group, not the 2 methyl group. Okay, this is the product student. This is up, dear student, we have to understand mechanism. So how can you be able to understand mechanism? Let us try to understand. If I am taking this one, right, and here is methyl group, here is bromine, here is hydrogen. Okay, here is also hydrogen, here is hydrogen. So OH is attacking here on this one, so as this is shifting here, and this is getting out. So that is, we have to take out the more number of alkyl groups. So this is our required product student, right? So like that you will be able to do the mechanism students, that is what somewhat ED. Now these all the product are known as Jatso product student, these all are known as Jatso product, Jatso product, or another term, or that is also known as, or that is Setjap product, Setjap product. Dear student, in the next video lecture I will try to explain you that is half month product. Okay, so keep watching student. If you find this video helpful, please do like and subscribe the channel, dear students.